All right, today we're jumping into one of the coolest parts of machine learning, the part where the machine basically teaches itself. Yep, you heard that right. We're diving deep into unsupervised learning. And it really all comes down to this one big question, right? How in the world can a machine just look at a giant, messy pile of data and find any meaning in it? Especially when there are no labels, no instructions, no teacher to guide it. Well, that's exactly what we're going to figure out. So what are we really talking about here? Look, with supervised learning, it's like you're giving the algorithm a study guide with all the answers. But with unsupervised learning, nope, it's pure discovery. We just hand the machine a bunch of raw data and say, go figure it out. Its entire job is to find the hidden patterns, the secret structure, all on its own. Okay, to make this super clear, let's try a little thought experiment. Imagine I just dumped 1,000 random items from a shopping mall right in front of you. We're talking laptops, t-shirts, apples, lipstick, coffee tables, the whole shebang, all mixed together. And here's the catch. There are absolutely no category labels. So where would you even begin?
Well, you'd do what any of us would do, right? You'd start putting similar things together. The laptop and the headphones, they're both electronic. The t-shirt and the jeans, they're both clothes. The algorithm does exactly that, but without the human brain. It's never been told what electronics or clothing even means. It just sees the similarities and starts creating these logical groups, these clusters, completely on its own.
So this whole idea of finding patterns in total chaos, it's not just some neat party trick. It's actually a huge deal. Let's get into why it's so important and take a quick look at how it all works under the hood. And here is the absolute key to why this is so critical. Just think for a second about the sheer amount of data being created right now. Every click, every sensor reading, every social media post, it's a tidal wave of information. And guess what? Almost none of it is labeled. Trying to manually sort through all that, it would be crazy expensive and take forever. So unsupervised learning is our way of taming that chaos. So how does this actually happen? It's a pretty straightforward process, really. First, you feed the machine the raw data, just the features, things like age, income, clicks, but zero labels. Then the algorithm just starts digging. It's actively looking for any patterns, any groups, any relationships it can find. And that leads to the third step, where it does its main job. It either groups similar data together into clusters, or it simplifies the data by boiling it down to its most important parts. In the final output, it's not a prediction. It's not a right or wrong answer. It's a map. It's the hidden structure of the data finally revealed.
Okay, let's zoom in on that third step, because that's where the real magic happens. There are basically two main ways this goes down. Think of them as the two biggest tools in the unsupervised learning toolbox. One is all about grouping, and the other is all about simplifying.
And it's pretty simple when you break it down. You've got clustering, and its entire goal is to group similar things together. Pretty intuitive. Then you have dimensionality reduction, which sounds complicated, but it's really about simplifying complex data. It takes a ton of features and boils them down to just the most important ones.
So let's look at a few of the big names in clustering. First, you've got k-means. This is the classic workhorse. You tell it how many clusters, or k, you want, and it goes to work. It's perfect for things like customer segmentation. Then there's hierarchical clustering. This one is cool because it builds a whole tree of nested clusters, which is super useful for organizing things like documents. And then there's DBSCAN. This one is the detective. It finds clusters based on how dense the data is, which makes it amazing at spotting the weirdos, the outliers, which is exactly what you need for fraud detection.
And what about that other tool, simplifying data? Well, you've got PCA, or Principal Component Analysis. It's a classic for a reason. The best way to think about it is like this. Imagine you have a really complex 3D object, and you shine a light on it to create a 2D shadow. The shadow isn't the whole object, but it captures its most important shape, right? That's what PCA does with data. It finds the most important components to make things way easier to see and handle. And then you got t-SNE. Oh man, t-SNE is an artist. It takes super high-dimensional data and creates these stunning 2D or 3D maps that are just beautiful. They're perfect for seeing how clusters are structured.
Okay, that's enough theory. This stuff isn't just sitting in a lab somewhere. You're actually interacting with it every single day. So let's talk about how unsupervised learning shows up in your real life, from your shopping habits to your bank security.
Let's start with a big one, customer segmentation. I mean, think about it. Every company out there is desperate to understand its customers better. They don't want to see you as just one giant faceless crowd. They want to see the specific groups, each with their own unique interests and habits.
And this is how they do it. These algorithms sift through everything. what you buy, what you click on, your general demographics, and they start to form groups. This is why you get ads that actually feel relevant, because marketing teams can stop blasting the same message to everyone and start talking to your group specifically. And sometimes it even finds totally new types of customers that the business had no idea were even out there.
All right, next up, let's talk about something that's constantly working behind the scenes to keep you safe: anomaly detection. Unsupervised learning is basically the world's best detective when it comes to spotting something fishy, something that just doesn't fit.
Yeah, its whole purpose in life is to find the odd one out. That credit card charge in a different country when you're at home? That's an anomaly. That weird spike in data on your company's network at 3 a.m.? That's an anomaly. A tiny little defect in a product on a factory line? You guessed it, an anomaly. These algorithms are like silent guardians, constantly on the lookout for those rare but super important events.
And finally, let's talk about a classic example. You've almost certainly heard of this one, even if you didn't know its official name: market basket analysis. This is all about discovering the secret relationships between the things people buy.
The absolute textbook example, it's almost a legend at this point, is that stores discovered that people who buy bread also tend to buy butter. And another famous one is that people buying diapers were often also buying beer. You know, maybe a little reward for a tough week of parenting? Finding those unexpected connections is pure gold for a retailer. It's why they place certain items near each other, and it's the engine behind every "people who bought this also bought" suggestion you see online.
Okay, so it's obvious this stuff is incredibly powerful. But hey, no tool's perfect, right? It's got its upsides and its downsides. So let's wrap this up with a quick, balanced look at the pros and cons.
So, on the plus side, the fact that it works with all that cheap, unlabeled data floating around is a huge, huge win. It finds patterns a human would probably never spot, and it's an amazing tool for just exploring massive data sets. But on the flip side, the results can be a little tricky to understand. There's no ground truth to tell you if you're correct, so you often need a real human expert to look at the patterns and figure out what they actually mean. So if there's one thing to take away from all this, it's this: unsupervised learning is all about discovery. It's our best tool for looking at a giant, messy pile of data and just asking one simple, powerful question: what's really going on in here?
So now you know what it is and why it matters. But are you ready to see how a machine actually does it? Like step by step, how does it really find the center of a group and build a cluster from nothing? That's what we'll be diving into next.